Hi everyone, welcome to this video on statistics. So today we will be dealing about statistics and what are the purpose of statistics, why do we need statistics, and what are the implications of statistics. So basically you may be familiar with statistics, basic terms and all, so I will just give you a brief idea of statistics and why do we need statistics in data analysis world. So as you can see, statistics is a branch of science which deals with collection, organizing, interpretation, presentation of data. So it's deal with data, so it's comprising everything which data. So in statistics there are many codes, and among them my favorite codes are these two. So there are three types of lies. So first one is lies, then we have damn lies, then we have statistics. And another by Joseph Stanley is by a single death is a tragedy, but a million death is a statistic. So from these quotes you may already got the idea of the powerful statistical world. So whenever we have a data, if we want to find something from that data, we need statistics. So how do we deal with data? So we have a bunch of data, but how do we deal with it? So for that, now we have the statistics, and we have many representation of statistics, I mean representation of data. So whenever I say statistics, it represent data. So first representation of data is descriptive statistics, and second is the graphical methods. So today in this video we will be discussing about descriptive statistics. So descriptive statistics, it's consisting of central tendency and dispersion. I think you may be familiarized with these all words: mean, median, mode in central tendency. Dispersion is range, variance, standard deviation. There are many other things in dispersion, but these six words are the most important thing that we need in descriptive statistics. So central tendency, as you know, the name in tells us, it tells uh, uh, about the data, what the data represent. So representation of data is central tendency. So dispersion is how the data is distributed, so that is dealt with dispersion. So when we go for the central tendency, we have mean, median, mode, and mean is the average of all the observation in a data set. So these words are mind language, so please don't use this for any academic purpose, because for academic purpose they may use a vast big definition, but to make it simple, I just give you a simple idea of what is mean of a data means. So it is given as the average of all the observations. So what is median? It's the middle value. So what is mode? It is a frequent observed value in a data set. So mean, as I said, average means, I think you may know already about it. It's summation of all the data divided by total number of data. So that is mean. So what is median? We have to first arrange the data in an order. It can be in ascending or in descending order. So after arranging, we have to find the middle value. So if it is odd number, we can get, so if it is 5, you have to divide 5 by 2, so you will get as 2.5. you have to round it to 3, so your third element is your median. And if it is an even number, let's say it's 6, so 6 by 2 is 3, but you have to take the average of third element and the fourth element, then you get the median value. So mode is frequently observing data. That is, if you have the element 1 is repeated 5 times and element 2 is repeated as 3 times, you will say the mode is 1, because 1 has occurred more. So we have dispersion. So after dealing with central tendency, which is the central value of the data. So what is this overall value of the data? So dispersion. So what is dispersion? It's the spreading of the data. So how the data is spread around the mean, that is dealt with dispersion. So in dispersion we have range. So what is range? It is the distance between highest and lowest value in the data set. So whenever you have a data set, you have a maximum value and you have a minimum value. So whenever you subtract the maximum minus minimum, you have the range. Next is variance. What is the variance? It's the distance from the mean. So it's the average distance. Let's say it's the average distance from the mean. So it will give you an overall idea about how the data is distributed around the mean value. So it can be formed from average of or each element square minus mean square. That is one way of doing it. The other way of doing it is by taking the average of each element minus mean the whole square. So the equation can be available in Wikipedia and every sources, so you can follow that. So what is standard deviation? So standard deviation is the square root of variance. So now you will have one question that if the variance is distance from the mean and standard deviation is square root of variance, why we need two equations, right? Why we need two things? So like variance and standard deviation, basically they are same, right? One is square and one is square root of the same thing. So this is because the standard deviation we cannot use for further theoretical purpose, or in the practical situations also standard deviations can't give us a proper impact of the data. So for that we use variance. So whenever we have a square value, so it will be a bigger value, right? So bigger value we can know, oh yeah, this is the correct value, or this much spreadness is there in the data set. So that's why for practical purpose and theoretical purpose only we are using variance, otherwise standard deviation was enough. So for that purpose we have variance and we have standard deviation. So this is about a basic idea of statistical tools that are needed for any analysis in the data. So next we will be dealing about how we can do this descriptive statistics in SPSS. Alright, let's begin in statistics program in SPSS. So now you may have probably have a doubt that when we have an open software, free software like Python and R, then is SPSS that much worthy in doing? Its answer is definitely no. It's completely no. SPSS cannot overcome the power of R language and also the Python language. Now the problem is that you have to know about the coding. So that is a problem. So persons who know coding, it's way too simple to do in R and Python. If a person don't know coding, then for them we have the SPSS. Now SPSS is more powerful than Excel. So this SPSS is made especially for statistics. So it's more powerful than Excel, but it is not powerful than R program and Python program. So let's begin about how to do the descriptive statistics in SPSS. So I have an parameter, so its name is age. So it's a numerical parameter. So you can see that it has numerical values. So it's a continuous values. Oh yeah, continuous values. So I think you know how to name or input some values in SPSS master sheet. So just you have to type what the values names is right here, and you have to give whether it is numerical or nominal or ordinal. So labels can be given here. So here you have numerical strings. So you have it's way too simple to do in SPSS. So if you don't know how to begin with SPSS, just comment below, so I make a video on that. Okay, so if you want to import a data set also, you can import from import data. You will have the Excel or you have the CSV data, so you can import those data into your SPSS master sheet. So you have to know about how to do the descriptive analysis, such as mean, median, standard deviation, variance. So always remember, we will do this mean, median, standard deviation, variance for numerical data type. So for numerical data type, we have to go for analyze, descriptive statistics, we have explore. So on the explore, you have to give age as the dependent list. So you have the age as the dependent list. Then you can give on the statistics descriptives. If you need outliers, you can give that percentiles. If you need, those also can be given. So percentiles, I'll talk about that more on another video, so you have a better idea on that. So there's no need of those things. Maybe on the next video I will tell about the percentiles. So click on OK. So here you have all the descriptives that are needed. So mean, you have 41.14, you have median, you have variance, you have standard deviation, you have minimum, you have a maximum, you have a range. So this is descriptive statistics of a data. So from this you can know that mean is 41.14. what does that mean? My age have a central value of 41, or the average age in my data set is 41-year-old people. So that were the average age, and it has a variance. Here you can see the variance is too big, so this data set has some sort of outlier. So this data set has outliers, maybe, yeah. So we have to be careful while doing with this data sheet. So variance, and we have standard deviation around 15. So so that's about descriptive analysis. So if it is numerical, if it is categorical one, then usually we don't go for descriptives. We don't usually give mean value. So if it is in categorical data, we if it is ordinal one, we go for median, and if it is nominal, we go for mode. Otherwise you can go for just descriptives. So here, if you have a categorical one, you can just give descriptives and click OK. You can have an idea of the descriptives values. So that's all for today's on the video of descriptive analysis. I will be uploading more videos about statistics in how to do in SPSS. So kindly press the like if you liked it, and subscribe button to get update of new videos coming soon. Thank you and bye bye.